dimension. It is the power of different fundamental quantities in a derived quantity. In a formula or in a derived quantity, what are the powers of the fundamental quantities? That is called as dimension. Suppose acceleration. Suppose I talk about acceleration. So acceleration is meter per second square. Meter is length and second is time. So if I write like I put a square bracket about it, then what I mean here is that you have to write down the dimensional formula. Dimensional formula tells us what is the power of length and what is the power of time in that physical quantity. How it is related to length and time, and also mass. So I can say the power of mass is 0, the power of length is 1, and the power of time is 2. That is called as dimensional. Dimension and dimension. This is called as dimensional equation or dimensional formula. So what is dimensional formula? Dimensional formula is a formula showing the power of different derived or different fundamental quantity in a unit.
Yes, sir.
Got it?
Yes, sir.
Clear?
Yes, sir.
Very good. See, it follows the rule of or the method of power. Okay? It follows the method of power. What I mean the method of power? So suppose we have a quantity A. We have a quantity A whose dimensional formula is MALBTC. And we have a quantity B whose dimensional formula is MXLYTZ. So if you multiply A and B, so this leads to multiplication of these two formula, MLBTC and MXLYTZ. And whenever we multiply power, like 2 to the power 3 multiplied by 2 to the power 4, so this is like 2 to the power 7. 3 plus 4 is 7. So here this will become M to the power A plus X, L to the power B plus Y, T to the power C plus Z.
Yes, sir.
Got it?
Yes, sir.
And if we have A by B, very good. M A minus X, L B minus Y, T C minus Z.
Yes, Z. Yes, sir.
Is it clear?
Yes, sir.
Now, what are the applications? So, application is principle of dimensional homogeneity, conversion of units, and to find the relationship among physical quantities. These are the application that we'll be getting.
Yes, sir.
So let's discuss one by one what we mean by all these words that I have written here. So the first is principle of dimensional homogeneity. What does this mean? Very simple. The meaning is very simple. It means that in an expression separated by plus sign, minus sign, or equal to sign, the terms will have same dimension.
Yes, sir.
What I mean by this? What I mean by this statement, that in an expression separated by plus minus equal to sign, The terms will have same dimension. This
Yes.
means that if x is equal to y plus z, then x, y, and z will have same dimension.
Yes, sir.
That means that you can add only Newton to Newton. You cannot add Newton to mass. You can't say, okay, this is 4 kg of rice and this is 5 Newton of force. Today I'll be adding 4 kg of rice and 5 Newton of force. You can't do that.
No, sir.
Only 5 Newton of force can be added to 4 Newton of force, but it can't be added to 4 kg of rice.
Yes, sir.
And the answer will again be in Newton. So I say x, y, and z will have the same dimension.
Yes, sir.
This is the principle of dimensional homogeneity. Now the second application is conversion of. So conversion of unit. See, suppose I talk about force. Suppose I talk about force. What is the SI unit of force? Newton. And what is the CGS unit of force? Dyne it is.
Right. Yes, sir.
Energy. What is the SI unit of energy? Joule. Energy and work are same thing.
Okay, sir.
And what is the CGS unit? The CGS
Okay.
unit is called as erg.
Yes, sir.
I have to convert N1 Newton to dyne. So I'll get N2 dynes. Okay, N1 Newton is equal to N2 dyne. Suppose I have to convert from Newton to dyne and I have to convert N1 Newtons. So how much will be the value of N2 that we have to find out here? Okay, now my question to you, Ferdin, is
Yes, sir.
what will be the dimension of Newton and what will be the dimension of dyne? What will be the dimension of Newton and what will be the dimension of dyne? Will it be different? Same?
Same, sir.
Same.
As
Because they
force.
are unit of force. And
Yes.
force has the dimension that they will have the same dimension.
Yes, sir.
So N2 is equal to N1 into dimension of force in Newton, dimension of force in dyne. Got it?
Yes, sir.
So we know that dimension of force is mLT minus 2. So I can write N2 is equal to N1 M1 L1 T1 to the power minus 2. I am denoting 111 for Newton and I am denoting 222 for dyne. Okay for this. So I have used 111 in the subscript. I have used 111 in the subscript to show that it is the dimension of Newton. And I have used 222 in the subscript to show that it is the dimension of dyne. But if you see the power, power remains same.
Yes, sir. Minus 2 minus 1.
Got it?
Yes, sir.
So I can write it further like this. N2 is equal to N1 into M1 by M2, L1 by L2, T1 by T2 minus 2. Got it?
Yes, I got it.
Now, M1 is Newton, M2 is dyne. So M1 is mass, M is mass. So M1 will be in kilogram and M2 will be in grams. So I can write this as N2 is equal to N1. This I will write as 1000 gram divided by 1 gram because M2 is in gram. And if I have to divide, I have to convert it into gram before dividing.
Yes, sir.
So 1 kg is equal to 1000 gram. L1 by L2, that is in meter, 100 centimeter divided by 1 centimeter. Second, 1 second divided by 1 second to the power minus 2. So you will see here that I get N2 is equal to N1 into 10 to the power 5. So this N2 is equal to this much dyne.
Yes, sir.
So I got that N2 is equal to N1 into 10 to the power 5 dyne. That means 1 Newton is equal to 10 to the power 5 dyne. So I have converted one unit to another. So what was here? This N1 was in Newton and
Yes.
N2 was in dyne. So I got N2.
Perfect. Yes, sir.
Understood?
Yes, sir.
Fine. Now I come to the third application. To find a relationship among physical quantities.
Yes, sir.
Suppose you are a scientist. Suppose
Yes.
you become a scientist. Okay, Fardeen. Now you are a scientist and you do a simple experiment.
Yes, sir.
You do a simple experiment and the aim of the experiment is to find time period of a simple pendulum. To find time period of simple pendulum.
Okay.
This is the experiment.
Yes, sir.
So you take a simple pendulum,
Yes, sir.
you oscillate it and you have a stopwatch.
Yes,
And you will see that in 10 oscillation it takes 40 seconds and you will say the time period is 4 seconds.
yes, sir.
So now what comes to your mind is that suppose if I increase the length of this simple pendulum, what will happen to the time period? How the time period will change if you increase or decrease
2
the length?
pi to the root of formula. Sir.
You want to know that how this will depend on length. Just you forget that you know even the formula. Just forget this formula. 2 pi root L by
Okay,
G.
sir.
This is a wrong formula. Suppose. Fine. So
Yes,
you
sir.
forget about, you don't know anything. How will this change? So you will
Yes,
write that time is proportional to length to the sum power x.
Yes, sir.
Then
Yes.
you take it to moon and you observe that time period again changes. So you come back and you say that time period is proportional. Time period is dependent on g also. Let's say some power of g.
Yes, sir.
Then you have a doubt in your mind that might be it can depend on the mass of the simple pendulum also. So you say, okay, let it depend on mass also, m to the power z.
Okay, sir.
So you will say that the unit of time is L to the power x, g to the power y, m to the power z, n is some constant k is some constant. Fine.
Yes, sir.
Now the unit of time period is m0, L0, t to the power 1.
Yes, sir.
K is dimensionless. This constant are just pure number, so they are dimensionless.
Yes, sir.
Now, dimension of L, m0, L to the power x, m to the power 0. Dimension of G is m0, L, t minus 2 to the power y.
Yes, sir.
Dimension of mass, m, L0, m, L0, t0, and this to the power z.
Yes, sir.
Got it, Fardeen?
Yes, sir.
What I'm trying to say, Fardeen,
Yes, sir.
that this is the formula that I got.
Yes, sir.
So the dimension of t is here,
Yes, sir.
the dimension of L is here, the dimension of G is here, the dimension of M is here.
Yes, sir.
All the three are in multiplication. Till here it is clear.
Yes, sir.
M0 L0 T1 is M0 LX T0, M0 LYT minus 2Y, MZ L0 T0. Is it fine?
Yes,
Because
sir.
this is raised to the power Y.
Yes, sir.
Now I know that it follows the rule of power. So
Yes,
this is M0 plus 0 plus Z. LX plus Y plus 0. T0 minus 2Y minus 2Y. The last one is MZL0 fine.
0.
T0 minus 2Y. 0. Got it, Fardeen?
Yes, sir.
So Fardeen, I am comparing now.
Yes, sir.
So 0 is equal to 0 plus z. So z is equal to 0.
Yes, sir.
Now I am comparing length. 0 is equal to x plus y. That means x is equal to minus y.
Yes, sir.
Now I am comparing time.
Plus 0.
Time is 1 is equal to minus 2y.
Plus 0.
So y is equal to minus 1 by 2.
Yes, sir.
So I get y is equal to minus 1 by 2, z is equal to 0, and x equals to 1 by 2 because x is equal to
Yes,
minus.
sir.
So time is k into L to the power x, that is 1 by 2,
By 2.
t to the g to the power y minus 1 by 2,
Yes, sir.
m to the power z 0.
Yes, sir.
So this becomes what? K into root L by g.
L by 2. Yes, sir.
We found out how they are related.
Yes, sir.
Got it?
Yes, sir.
So we have seen the application. These are the three types of question that you will get from unit and dimension in your examination.
Yes, sir. Yes, sir.
Unit and dimension has some limitation. And I have written down the limitation here.
Yes, sir.
That you cannot use to derive equation involving addition and subtraction.
Yes,
See,
sir.
I derived the equation under root L by G. But you cannot use this method to derive an equation where there is plus and minus sign involved.
Yes, sir.
Like you can't derive an equation like if an equation is that force is equal to something plus something. You can't derive such equation.
Yes, sir.
Only when they are in multiplication or division, then only you can derive.
Yes, sir.
Numerical constant having no dimension cannot be obtained by the method. See, I derived the formula t is equal to some constant in root L by G. But I was not able to find out the value of k.
Yes, sir.
That is the limitation of this method.
Yes, sir.
Dimensional method fails when number of variable is more than number of equation. This is true for anything. If you have 3 equation and 3 variable, you can solve it. But if you have 4 variable and 3 equation, you cannot solve it.
Yes, sir.
Equation using trigonometry, exponent log cannot be deduced. This is very important. Fourth point is the most important point here. What it means that if I have y is equal to log 3x, then this is dimensionless. This is dimensionless because this is dimensionless. Fine. This 3x is a pure number. This is also dimensionless.
Yes, sir.
3 into x is a dimensionless pure number.
Yes, sir.
So in an equation, if there is trigo, exponent, log, sine, cos, tan, all this, you can't derive those formula using this method.
Yes, sir.
Because they are dimensionless.
Yes, sir.
Got it, Farbin?
Yes, sir.